Using fork conductor non-metallic sheath cable, also known as NMB cable, for a dead-end four-way switch is permissible, provided you properly re-identify the conductors. This involves repurposing one of the grounded, typically white, conductors as an ungrounded or hot conductor for switching purposes. The NEC, or National Electrical Code, permits re-identification of conductors under certain circumstances. Ensure you adhere to all applicable codes and safety precautions. The process involves several steps. Firstly, identify the grounded conductors within the four-conductor NMB cable. Typically, in four-conductor NMB cable, the grounded conductors are identified with white insulation. These white wires are intended for use as neutral conductors in a standard circuit. Secondly, re-identify one of the grounded conductors. To repurpose one of the white grounded conductors as a hot conductor, you must permanently re-identify it using electrical tape or heat shrink tubing. Apply black or red electrical tape or heat shrink tubing to completely cover the white insulation near the ends of the wire, indicating that it is now a hot conductor. This re-identification must be done at all points where the conductor is accessible, including inside the switch box and at the electrical panel. Thirdly, connect the hot conductors to the four-way switch. Connect the re-identified hot conductor, which is now marked with black or red tape or heat shrink tubing, to the common terminal of the four-way switch. This terminal is usually identified with a darker screw color, often black. Connect the other hot conductor, typically the black wire in the NMB cable, to one of the traveler terminals on the four-way switch. The traveler terminals are used for the two wires that connect the four-way switch to the three-way switches in the circuit. Fourthly, connect the grounded conductors. Connect the remaining white grounded conductor, which has not been re-identified, to the neutral bar in the electrical panel. This provides the necessary neutral connection for the circuit. Fifthly, connect the feed. Connect the black feed wire from the electrical panel to the supply terminal of the four-way switch. This wire brings the power from the circuit breaker to the switch. Several notes must be kept in mind to ensure safety and proper operation. Ensure that the four-way switch is rated for the amperage and voltage of the circuit. Check the switch packaging or markings to verify that it is suitable for the intended use. Use proper wire connectors, such as wire nuts or push-in connectors, to make all electrical connections. These connectors should be appropriately sized for the gauge and number of wires being connected. Tighten all connections securely. Loose connections can cause arcing, overheating, and potentially electrical fires. Double-check all connections before turning on the power. Visually inspect each connection to ensure that the wires are properly seated in the connectors and that the connectors are securely fastened. Now let's talk about some critical safety considerations to always follow when dealing with electricity. Turn off the power. Before working on any electrical circuit, turn off the power at the circuit breaker or fuse box. This prevents accidental electric shock. Test for voltage. Use a non-contact voltage tester to verify that the power is off before touching any wires or terminals. Follow local electrical codes. All electrical work must comply with local electrical codes and regulations. If you are not comfortable performing electrical work, hire a qualified electrician. Wear appropriate safety gear. Wear safety glasses to protect your eyes and insulated gloves to protect your hands from electric shock. Never work on wet surfaces. Avoid working on electrical circuits in wet or damp environments, as water increases the risk of electric shock. Use insulated tools. Use tools with insulated handles to reduce the risk of electric shock. Avoid overloading circuits. Do not overload electrical circuits by plugging in too many devices, as this can cause overheating and electrical fires. Inspect wiring regularly. Regularly inspect electrical wiring for signs of damage, such as frayed insulation or loose connections. Now let's discuss wire gauge and ampacity. Wire gauge refers to the physical size of the wire, typically measured in American wire gauge, or AUG. The smaller the AWG number, the larger the wire diameter. Ampacity refers to the maximum amount of electrical current, measured in amps, that a wire can safely carry without overheating. The appropriate wire gauge for a given circuit depends on the ampacity of the circuit breaker or fuse protecting the circuit. The NEC provides tables that specify the allowable ampacities for different wire gauges and insulation types. For example, a 14 AWG copper wire with type THHN insulation is typically rated for 15 amps, while a 12 AWG copper wire with type THHN insulation is typically rated for 20 amps. A 10 AWG copper wire with type THHN insulation is typically rated for 30 amps. Using a wire gauge that is too small for the circuit ampacity can cause the wire to overheat, leading to insulation damage, electrical fires, and equipment failure. It is crucial to select the appropriate wire gauge based on the circuit ampacity and the applicable electrical codes. Now let's discuss common mistakes to avoid. Improper re-identification. Failing to properly re-identify the grounded conductor can lead to confusion and safety hazards. Always use black or red electrical tape or heat shrink tubing to clearly mark the re-identified conductor. Loose connections. Loose connections can cause arcing, overheating, and electrical fires. Ensure that all wire connectors are properly tightened and that the wires are securely seated in the connectors. Over-tightening can also be an issue, as you can damage the threads on the wire connectors. Overstripping insulation. Stripping too much insulation from the wires can expose bare conductors, increasing the risk of short circuits and electrical shock. Only strip enough insulation to make a secure connection. Using the wrong type of wire connectors. Using the wrong type of wire connectors can result in unreliable connections and potential safety hazards. Use wire connectors that are specifically designed for the type and gauge of wires being connected. Ignoring electrical codes. Ignoring electrical codes can lead to unsafe installations and potential legal liabilities. Always comply with local electrical codes and regulations. Working with live circuits. Working with live electrical circuits is extremely dangerous and can result in serious injury or death. Always turn off the power at the circuit breaker or fuse box before working on any electrical circuit. Neglecting to test for voltage. Neglecting to test for voltage before working on an electrical circuit can lead to accidental electric shock. Always use a non-contact voltage tester to verify that the power is off before touching any wires or terminals. Overloading circuits. Overloading circuits by plugging in too many devices can cause overheating and electrical fires. Avoid overloading circuits and use surge protectors to protect sensitive electronic equipment. Improper grounding. Improper grounding can lead to electrical shock hazards and equipment damage. Ensure that all electrical circuits are properly grounded according to electrical codes. Now let's talk about troubleshooting common issues. Switch not working. If the four-way switch is not working, check the connections to ensure that they are properly made and that the wires are securely seated in the connectors. Also check the switch itself to ensure that it is not damaged or defective. Lights flickering. If the lights connected to the four-way switch are flickering, check the connections to ensure that they are not loose or corroded. Also check the voltage at the switch to ensure that it is within the proper range. Circuit breaker tripping. If the circuit breaker for the four-way switch is tripping, check the wiring for any signs of short circuits or ground faults. Also, check the amperage of the circuit to ensure that it is not being overloaded. Now let's discuss advanced wiring techniques. Three-way and four-way switch combinations. Three-way and four-way switches can be combined to control lights from multiple locations. The three-way switches are typically located at the beginning and end of the circuit, while the four-way switches are located in between. Multi-wire branch circuits. Multi-wire branch circuits can be used to supply power to multiple outlets or lights using a single circuit breaker. These circuits share a common neutral conductor and can reduce the amount of wiring required. Smart home integration. Four-way switches can be integrated with smart home systems to allow for remote control of lights and other devices. These systems typically use wireless communication protocols such as Wi-Fi or Zigbee to connect to the switches. Now let's talk about understanding electrical diagrams. Electrical diagrams are used to represent electrical circuits and components. These diagrams use symbols to represent different components such as switches, outlets, and lights. Understanding electrical diagrams is essential for troubleshooting and maintaining electrical systems. Single-line diagrams. Single-line diagrams are simplified representations of electrical circuits that show the major components and connections. These diagrams are often used for power distribution systems and large electrical installations. Schematic diagrams. Schematic diagrams are more detailed representations of electrical circuits that show all of the components and connections. These diagrams are often used for electronic circuits and control systems. Wiring diagrams. Wiring diagrams show the physical layout of electrical circuits, including the location of wires, connectors, and components. These diagrams are often used for installing and troubleshooting electrical systems. Now let's talk about using test equipment. Multimeter. A multimeter is a versatile test instrument that can be used to measure voltage, current, and resistance. It is an essential tool for troubleshooting electrical circuits. Clamp meter. A clamp meter is used to measure current without having to disconnect the circuit. It is particularly useful for measuring high currents. Non-contact voltage tester. A non-contact voltage tester is used to detect the presence of voltage without having to touch any wires or terminals. It is a valuable tool for ensuring safety when working on electrical circuits. Insulation resistance tester. An insulation resistance tester, also known as a megometer or megger, is used to measure the resistance of insulation. It is used to detect insulation breakdown and potential safety hazards. Now let's talk about NEC requirements. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. It is updated every 3 years and is widely adopted throughout the United States. Article 200. Branch circuits. Article 200 of the NEC covers the requirements for branch circuits, including the types of wiring methods permitted, the ampacity of conductors, and the overcurrent protection requirements. Article 300. Wiring methods. Article 300 of the NEC covers the general requirements for wiring methods, including the types of cables and raceways permitted, the installation requirements, and the protection requirements. Article 404. Switches. Article 404 of the NEC covers the requirements for switches, including the types of switches permitted, the installation requirements, and the grounding requirements. Article 250. Grounding and bonding. Article 250 of the NEC covers the requirements for grounding and bonding, including the types of grounding electrodes permitted, the grounding conductor sizing requirements, and the bonding requirements for metal enclosures and equipment. Understanding and complying with the NEC is essential for ensuring the safety and reliability of electrical installations. Now let's talk about energy efficiency. Energy efficient lighting. Using energy efficient lighting, such as LED bulbs, can significantly reduce energy consumption and save money on electricity bills. Energy efficient appliances. Using energy-efficient appliances such as Energy Star certified refrigerators and washing machines can also reduce energy consumption and save money on electricity bills. Smart thermostats. Smart thermostats can be programmed to automatically adjust the temperature based on occupancy and time of day, reducing energy consumption and saving money on heating and cooling costs. Proper insulation. Proper insulation can help to reduce heat loss in the winter and heat gain in the summer, reducing energy consumption and saving money on heating and cooling costs. Now let's talk about future trends in electrical wiring. Smart homes. Smart home technology is becoming increasingly popular, allowing homeowners to control lighting, appliances, and other devices remotely. This technology requires advanced electrical wiring and communication systems. Electric vehicles. The adoption of electric vehicles is increasing, requiring the installation of charging stations in homes and businesses. These charging stations require dedicated electrical circuits and safety features. Renewable energy. Renewable energy sources, such as solar panels and wind turbines, are becoming more common. These systems require specialized electrical wiring and equipment to connect to the electrical grid. Wireless power. Wireless power technology is being developed to allow for the transmission of electricity without wires. This technology has the potential to revolutionize the way we power our devices and homes. Now, let's reinforce some of the best practices we've discussed. Always prioritize safety. Electrical work can be dangerous, so it's essential to prioritize safety at all times. Follow all safety precautions and use appropriate safety gear. Comply with electrical codes. Electrical codes are in place to ensure the safety and reliability of electrical installations. Always comply with local electrical codes and regulations. Use quality materials. Using quality materials can help to ensure the longevity and reliability of electrical installations. Use wire connectors and other components that are designed for the specific application. Make secure connections. Loose connections can cause arcing, overheating, and electrical fires. Ensure that all connections are properly tightened and that the wires are securely seated in the connectors. Double-check your work. Before energizing any electrical circuit, double-check your work to ensure that all connections are properly made and that there are no potential hazards. By following these best practices, you can help to ensure the safety and reliability of your electrical installations. Now, in conclusion, using 4-conductor NMB cable for a dead-end 4-way switch is a viable option when properly executed. The key is meticulous re-identification of the grounded conductor, adherence to NEC guidelines, and unwavering attention to safety protocols. Remember to prioritize safety, comply with codes, and double-check all connections.